Hi everyone, and thanks for attending today's webinar, How to Choose the Right Data for Your Chart. My name is Jason Beres. I'm the Senior VP of Developer Tools at Infragistics, and my email is jasonb@infragistics.com. So my job here at Infragistics is I manage the Developer Tools division, and I really focus on helping customers do their jobs easier and better. So it's really important that we bring out this quality, ease of use, reliability in our product. And you'll see some of the samples today that I'm going to show you where I believe we've done just that. I've been at Infragistics for 11 years, going on 12. I was an MVP for 11 years. That just ended this year. I've done tons of presentations, keynotes over the years, founded the Florida.net user group and the New Jersey.net user group, and I've authored, co-authored 10 books over the last 15 years, ranging from SQL Server, VB, C#, ASP, .NET, and Silverlight. So today we are going to talk about charting. We're going to talk about encoding data into visual objects, understanding how you get to the answer of the chart to choose. We'll look at some bad data visualizations and how they can get better, and some really awesome resources that will help you in your journey to understand charting and making the most out of the visualizations that you're trying to deliver in your applications. So before we get started, I just want to highlight that everything we talk about today is available in Infragistics Ultimate, so make sure you download it. It is everything you need to design and build enterprise-ready apps for every major platform and device. So if you've been a customer for a long time, you know that we cover everything from prototyping to desktop development, cross-platform web, and mobile native UI. If you're new to Infragistics, you should check it out. All of the data visualizations, the charts you're going to see today, are just the tip of the iceberg of what you get in Infragistics Ultimate. We have Indigo Studio, which is our prototyping tool, and then for every desktop, web, and native platform, we have killer controls besides the charts, which include grids, calendaring, scheduling, editors, based on the platform. So we're really right there with you in what you need based on what you're trying to build. One of the neat things that we shipped late last year, we just delivered an update in January, was around Xamarin Forms. So if you want to create beautiful visualizations and charts for iOS, Android, Windows Phone, and you're a C# developer, then we have you covered with Xamarin Forms. It makes it really simple to use your current coding skills to deploy those to multiple platforms. In January, we shipped a killer jQuery dashboard. You can download this from the web. It shows some really nice visualizations tied together in a beautiful dashboard. We just in February shipped a Windows Forms dashboard, which again, everything you see today is available in Windows Forms, and you can build it very easily, just as if you were a previous WPF or Ignite UI developer. You have the same APIs and the same capabilities now on Windows Forms. And then coming this month, we're going to ship another cool dashboard and visualization scenario in Xamarin Forms. So you'll get it on Windows Phone, Android, and iOS based on the target that you'd like. So we'll really have you covered on every platform, for every device, for the data visualizations and charts that we're going to talk about today, plus a lot more. So let's talk about charting. So what we're going to talk about today is not necessarily an intro to charting. I have Charting 101, but it's really about understanding charts, why they're important, and then getting into the details as to when to choose a certain chart that will represent the data that you're actually using. So what is a chart? According to Wikipedia, of course, the source for everything, it is a graphical representation of data in which the data is represented by symbols such as bars in a bar chart, lines in a line chart, or slices in a pie chart. So this is a real simplification of what a chart actually is. Really, when we think about a chart, we have qualitative or quantitative data that we are trying to display based on a time series, based on a category series, and it could come in different fashions. So in these examples, we have bar charts, we have a trend line on the chart on the right-hand side, but today you're going to see a bunch of different charts and then the scenarios which you would use those charts in. And charts can be fairly simple, like the ones you see here, or they can get very complex based on your data. So if you think about a more advanced chart, like a tree map or a funnel chart, it's not very common to use those types of charts, but they're available based on the type of data that you may need to display. So one of the kind of neat things I learned many years ago, but I also was refreshed of it last month in Tobias Kamishki's webinar on data visualization. And if you did not see that, please go to Infragistics.com. Actually, just go to blogs at Infragistics.com. You'll see a blog which we posted, which you can replay the entire webinar on YouTube. But we did, Tobias did do a webinar last month, again, on data visualizations, and he really highlighted how we're programmed to think visually. So he did a quick test where he displayed this table and said, you know, how quickly can you find the tallest person? And of course, it's very difficult to scan that information when it's in that fashion. But if you look at it in a data visualization, it becomes very simple to actually see. So the whole point is we have a parallel and serial way of looking at the world. In reality, we want to see things in a visual image so we can actually remember it and we can analyze that data quickly. So now it's very easy to see that item number 4 is the tallest person. Now you would have figured that out had you looked at the table on the left, but if you started with a chart or a graph like we have on the right hand side, you can actually get to the answer quicker. So our brain is programmed to look at visual things, decompose them very quickly, but also remember them over time better. So this is really called active vision. So active vision really defines how graphics are cognitive tools that extend what our brain remembers. Irrelevant information is removed from our brains and replaced with new information every second. So our active vision is really what we're looking at in the moment, our field of information that we can draw from to make decisions, to create hypotheses, or to ask more questions. If you start to think about visuals and graphics and a person's active vision as cognitive tools, then you can really start to craft your visualizations in a way that will be memorable. So for example, a chart ends up being this tool that our brain can use to help solve problems. Just the same way that table could, but we can do it quicker and we can actually remember it if it's in a visual fashion on the screen. So the one thing to remember is our brain processes around 5% of the visual world as our eyes move. So information is constantly being refreshed in our brain, and it's being forgotten and then remembered and then forgotten and then remembered. So as you're looking at things like charts or dashboards, you have to make sure that you're telling the right story, but you're also getting the person's attention so they actually remember it. So selective visual attention really uses cues that help us remember the stuff on the page. So you can use signal techniques such as color, shape, tilt, arrow, etc. to tell your story more with your visualization. So in the examples I have on the screen here, where we have a bunch of points on a graph, it's very hard to tell the difference between any of them. They're basically all identical, and if you look at them too long, they actually become blurry. The two sort of optical illusions on the right, this guy here, the third item, are you looking at two people looking at each other, or are you looking at a white vase in the middle? On this screen here, are you looking at a beautiful woman with her head turned, or an older woman, you know, sort of with a big nose and a big chin? They're very hard to actually decipher what the heck you're looking at. So you want to ensure that when you create your visualizations and you integrate them into dashboards, that you're actually using the right signal techniques to capture a person's attention so they actually remember what the heck they're looking at. So in this case, I have a few examples of a tilted arrow or a larger highlighted sphere, or in a set of arrows, a square. Again, not the most complicated examples, but they do highlight those points of data, and they will make you remember these pieces as we move on. So if you're thinking about a chart or a data visualization, think about the colors that you're using in the chart. Is the tallest item the one that you want to call out in a different color or a bolder color than the other items? Are you using annotations to highlight pieces of information so they make more sense, or so that they're remembered more? Just think of that when you're doing your visualizations, and think that the human brain is constantly forgetting things, and it's very busy in its field of vision. You want to make sure that your data actually sticks. So Tobias had a beautiful modern dashboard in his webinar. I'm going back to something that's been around forever. This is like a really old school sort of dashboard on a car. But you can see even to back when, whatever this was, 1960 or 70, I really don't know, the most important items kind of stuck out, and they're designed in a fashion that are easy to read and they're memorable. So RPM is very important, and miles per hour is very important. Things that are less important is, what's the water temperature, what's my oil temperature, what's my pressure, because those things have a less likelihood of actually changing or being dramatically different, so I have to worry about them. RPM I do have to worry about all the time, because if my RPMs go too high, my engine can blow up. So again, if you think about how dashboards are designed in real life in airplanes and automobiles and tractors and trucks, you'll get the idea that thought has gone into how that data is displayed, and how these individual visualizations, in this case individual gauges, are designed to make that information stick and make it more relevant. So what we're going to talk about today are chart types. Chart types are usually based on different data models or data requirements. So when we talk about a chart type, you say, hey, we're going to do a pie chart, we're going to use a funnel chart for this, we're going to use a column chart, a line chart, a histogram chart. So in the general terminology, a chart type is usually based on a different data model. So I wouldn't use, for example, all numeric data. If I was going to do a pie chart, for example, I would need some alphanumeric data, and I would need numeric data or percentage of a whole data. A funnel chart's a little bit different than a pie chart, even though they kind of look the same, where a funnel chart does not equal all parts of the whole. They're just percentages of each part of the series of data that you're talking about. And then on the right hand side, this is a line chart, and we're essentially just connecting two dots based on a numeric scale with an alphanumeric labels on the bottom. Now another word we tend to use is the series. So a chart series represents the data model, or the values that can potentially be layered on top of each other. They are what is most of the time or always in the center of the chart, and you hear things like the category series because data is displayed on categorical subdivisions, like a line bar or a line chart, a bar chart, a stack chart, or a financial series chart. So you have financial data that you're plotting. So as we go through the different charts today and you start to learn about types of series data that you can plot, you'll get an idea of where these terms come in and what to look for in your data when you want to plot your charts. So if we look at your basic chart, let's break down what goes into the chart. So we have our x-axis, and the axis really provides the scales, quantitative and categorical, that are used to assign values and labels to visual objects. So the x-axis in this case is along the bottom of the chart, and then the y-axis is on the side of the chart, on the left and right. So based on your chart type, you may have alphanumeric values or categories on the x-axis and your numeric scale on the y-axis, but you can also have that reversed. So this is a column chart. A bar chart would be reversed, where the x-axis or the y-axis would actually have my my alphanumeric category, and then the x-axis would have my numeric data. We'll talk about what the difference and when you would use those throughout the presentation. But the idea is, based on your chart type, you either have numeric y, an alphanumeric y, a numeric x, or an alphanumeric x, or a combination of those data types to display your chart data. In the middle, where you see our columns right now, are the values of data that we're going to represent. So the values are encoded as visual objects positioned in relation to the axes. So here we have bars based, this is a time series, data based over time, showing a quadrillion BTUs of energy production per country. So we have the x-axis, which is showing our time series. The values are in the center of the chart, shown as columns, and the y-axis is the scale of data that we have in our data source. Some other aspects of the chart, we have our title and subtitle at the top, and then of course the legend on the right-hand side. So when you think about all of the things that make up this chart, together they tell the story that you're trying to tell for whatever you're trying to get across to your user. Are you trying to show ranking? Are you trying to show distribution of data? Are you trying to show data over time? And then as you can enhance your charts further, you can use things like crosshairs as people hover over charts. You can use tooltips as people hover over individual columns. You can annotate various areas of the chart. So these are the core chart pieces. These are the core pieces of a chart, excuse me, but there's other attributes that you can add to a chart to spruce it up based on the device that it's displayed on. If it's a mouse or if it's touch, you may have different features in your chart. So when we think about charts versus dashboards versus reports, Tobias covered this as well in his webinar. So again, I recommend you go visit that webinar online because it was really a good presentation. But he talked about this continuum of complexity. So I want to highlight that today when we talk about single charts and what goes into a single chart, those fall on the far left of this continuum where you have the least amount of context and complexity in your visualization. And then as you go into a dashboard, which we sort of have in the middle here, you get more context. You can see that the single chart just had expenses, but in the dashboard we're talking about expenses, income, net worth, and budget. So we have multiple charts which make up this dashboard. So that gets a little more complex, but it has a lot more context to the story that we're trying to tell to the person that's consuming this data, so they can make better decisions and they can do stuff with this information. Then on the right-hand side, we have the most context, but the most complexity. So this is just a tabular report. This is where you get into those complex reports. It could be flat data, it could be hierarchical data, but it's not as easy to understand. It's not as easy to get summary data, and mostly because it's 100% text. We have to do all the work ourselves. So on this different continuum, based on the depth of analysis that you need to do, is what you need to decide on what you're going to deliver to your end users for what they need. Now, it's very common today to have drill down scenarios. So if you think about just a single chart, if I tap on something, perhaps it brings up another chart with more detailed information. Or in Report Plus, which is our native dashboarding and analytics app that you can get for iOS and Android off the App Store, you actually click on a chart and it shows the table data behind it, so you can have a little more of that in-depth analysis, but you also get the benefit of the simplicity and the visual representation of that data. So again, based on what the user's needs are, you have to determine what you can deliver, but there are tools like Report Plus and even all of the Infragistics charts which do allow a level of drill down, so you can show your users both options for looking at data. And so really, when we think about charting and visualization and data, it's all about helping people understand complex information faster. So we talked about this active vision and how our brain works and how we remember data. So charts can take this rich data and really make it consumable. Multiple charts make up dashboards which display one or more visualizations to help users make those decisions that will make better business decisions, get their jobs done easier, help them get to an answer quicker without going through mounds of textual data. So there's an example of one of our samples called IG Election Center, which in this case the visualization is a map. So we have a distribution of votes over the states, and the red states were the Republicans, the blue states were the Democrats, and the green or the gray states were James Weaver. It looks like the greenback which it looks like he didn't get much. So James Garfield ended up winning that election. And then here's another sample of a dashboard that we shipped with our WPF product a few years ago. This is called XAM Trader. And then as we go through some of the demos later, you'll see some of the newer dashboards that we're shipping on the different platforms. So let's get into encoding data into visual objects. So it can get very sort of complex if you go to even the Infragistics website and look at all of the chart types that we have. So there's tons of chart types. We have over 55, 60 different chart types, and they go well beyond your common business scenarios. So if you're looking to display almost any kind of data, we have it in the product, but at the end of the day, in almost every case for a business-focused chart, you can encode your quantitative data using one of these visual objects: points, lines, bars, and shapes. It's really that simple. So even though there's a ton of options for charting, and some of them get to be quite fancy, and the way we've set up our product is that you can do customizations, and essentially you can create your own custom series for almost any chart. And the reason is that we don't want to hold you back for what you actually need to deliver to your customers, but we also need to make it easy to use if you don't want to do custom charting. So I'm going to focus today on just the core business scenarios for the charts that you would need. So let's take a look at each one of these and the types of charts that would go with it. So points. Points are any shape used to specify a location on the graph. They can have a numeric y and a numeric x and a y-axis, but they can also have a numeric x and a category y. Category y meaning that on the y-axis you can have a non-numeric label. So essentially, if you look at any type of distribution or numeric data that you need to display, you can use a point to display it. When we think about the types of point charts that we would use, a couple come to mind. Here we have sort of a scatter plot, and on the right-hand side we have a typical bubble chart. Usually when we're trying to display some sort of quantitative data, we are using points connected by lines. So it's more difficult to decipher point-based data that's just kind of sitting in space. So a lot of times when we do talk about points, we talk about a line chart or points with lines, because those points are connected. So if you think about something that has a numeric x and a category y axis, the category y may be something like a time-based data. Next we have lines. Lines are a collection of individual contiguous points extending in a single direction to connect individual data points, to display the trend of a series of data points. So you can have a numeric x and y axis, you can have a numeric x category y axis, or even a time series. So when a line is used to connect individual values, it isn't necessary to display those values as points in addition to the line. So in the previous slide we talked about points being connected by lines, so it's a point chart, a point plot with lines. With a straight line chart, especially when you have data over time or you're trying to display trends of a series of points, you don't need to have the actual points themselves. The lines actually just make up the visualization that you're trying to see. Bars are thick lines with quantitative information represented by a bar. It involves a length and its endpoint relative to the quantitative scale to one or both axes. So it can have a numeric x category y axis or a time series, and it can be bars that are either horizontal or vertical. So when we think about a bar chart versus a column chart, you get the idea below. So the chart on the left is a column chart, the chart on the right is a bar chart. Now, a lot of times they're very simple. So we could have, for example, sales by month of a certain store, and that would just be one bar per month. In this example, we have multiple data points, multiple values being compared. So we have in January, there's actually 4 columns. February, there's 4 columns. If we had the legend, we'd be able to say, hey, that could be performance by salesperson. It could be year over year. It could be 2010 through 2014, and each bar represents a different year. But those are just based on the series data that you're trying to bind to your chart. On the right-hand side, we've sort of flipped it. So on the y-axis, we have our category y, and on the x-axis, it's a numeric value. So here we have some performance of something over months. It's just kind of flipped on its side compared to the column chart on the left. It's important to note when you're looking at any bar sort of graph that the thickness of the bars really doesn't matter. So if you have super thick bars or super thin bars, the bar isn't actually representing the data value. The scale, either on the x or y axis, to the endpoint of the bar is the value that actually matters. So then finally, shapes. When we think about shapes, they're quantitative values representing a value in proportion to a whole. They can have a numeric x category y-axis, and unlike a bar chart or a line chart or a point chart, it's not obvious what the axis is. So in the case of a shape, the perimeter of the circle is actually the axis data. And so you can see on the left-hand side we have a pie chart, and this is an example of what's considered a pattern called small multiples. So the large blue slice of the pie, which is part of the whole, is broken out into even more detail in a stacked bar chart. And on the right-hand side, we have a donut chart, which has different series of data to represent, different months of the year against some value. Now, in the charting world, pie charts are very popular. In fact, at Infragistics, they are the #1 requested chart type of any platform we have. So, when we ship the new Xamarin Forms, if we don't have pie chart, customers start getting upset. But if you talk to the guys that you read about, for example, one of the references you'll get out of this presentation is Stephen Few in all of his books. He says never use a pie chart. In fact, he has an article that says leave the pie for dessert, because it is not something that you want to put in any business scenario, because it's very difficult to understand the scale when you're looking at something distributed over a circle like this. It's much easier to represent the pie chart as a column chart, for example, or even a line chart. When we get into some of the good and bad examples later, you'll see how we take these pie chart examples and make them better. Though I know everyone on the webinar is going to use pie charts and has used pie charts, the experts recommend actually against using pie charts in a real business scenario. So, understanding the questions you are trying to answer, this kind of gets to the crux of determining your chart type. So what quantitative data are you trying to display? So we just went over the types of displays that you can do. You had your point, your bar, your line, and your shape. So how do you translate this into the correct chart type? So you have to start asking yourself questions. Am I trying to measure performance? Do I have one or more variables? Is my data time-based? Is it geospatial? Can I put it in a map? How many data points do I have? Do I have 1 million data points? Well, if I have 1 million data points, I can't display it in a bar chart. Would I have to use a scatter plot, for example? Are you comparing different categories of data? So do I need a numeric x-axis and potentially, or an alphanumeric x-axis and an alphanumeric y-axis, or a combination of both? Or do I have to have an additional axis, an x2 or a y2 axis? It all depends on what your data looks like and really what you're trying to represent to the user. So the bottom line is, how do I know when to use a point, line, bar, or shape, or something else? So I'm going to give you some resources at the end of the presentation which don't map to necessarily what we have here. What I'm using, because it's worked really well for Infragistics in a few ways, is some recommendations by Stephen Few, who's a noted data visualization expert. He's written a ton of books, and if you haven't gotten any of them yet, you will after this talk, because he has some amazing free information on his website and just as equal amazing information in his books. But there's other ways that people have categorized how to actually determine the data to display. Now, the way Infragistics uses this information is we've taken this and sort of modified it into our own when we built Report Plus. So Report Plus is an app that looks at data and it recommends chart types based on your data. And that's the app I mentioned earlier. You can go to the App Store, grab it, bind it up to one of your Excel charts, and you can start creating visualizations right away. But the bottom line is you need to make sense, or you need to break down somewhat the many chart options into relationships that you would use to actually display data. So Stephen Few breaks it down into 7 different types of relationships. So he has nominal comparison, time series, ranking, part to whole, deviation, distribution, and correlation. So let's talk a little bit about these. So nominal comparison displays a series of discrete quantitative values so they can be easily seen and compared. So if you think about questions like how much did she make? Well, she made more than them. How big is it? It's bigger than the rest. What's the salary by department? You can display these in any number of the options we have below. So a bar chart would display it very well. So I can have discrete values and then compare them over either a category Y or a category X axis in a column or bar chart with a numeric Y or X based on how I'm trying to display data. A point chart would also work. And I also have a map down here for geospatial data. So let's say I wanted to do population by state. It would be very easy to do it in some sort of a scatter plot. I could probably get away with maybe not a bar chart or a column chart. It's probably too much data, but a map would work perfect because I could have what's called a choropleth map, which shows, which takes 2 to 4 colors from light to heavy, and it distributes those colors over the map, and it could show me the weight of the value that I'm trying to bind to each individual state, which would represent population. So a map would also work in a nominal comparison as well. For a time series, we want to show data values that are associated with a categorical subdivision of time. So this is pretty straightforward. You want to show years, quarters, months, weeks, days, minutes, or even seconds. The type of relationship is treated separately because of the characteristics of time when displayed graphically. So we don't just say this is a category X type of scenario. It's actually a time series, because if you want to change the time values, the chart needs to understand what those measures are so they can actually be represented effectively in the chart. So this is probably one of the absolute most common business chart types. In fact, most of the charts I look at every day are almost exclusively time series charts when it comes to all of the financials for dev tools and sort of what we're doing as a business and how I monitor the business. So there's 3 chart types that you could actually use: a line chart or a point and line chart, which we talked about earlier. Column charts are very common for displaying time series on your x-axis and then your scale on your y-axis, or trends over time with a scatter plot and then a trend line. So if I want to show like change in data values, rises, increase, fluctuations, growth, decline, decreasing or increasing values, you want to display with one of these chart types, and you want to use a time series. Ranking shows individual quantitative values associated with a set of categorical subdivisions and how they relate to each other sequentially by size. So data is displayed from highest to lowest or lowest to highest. The important thing here is that your data, it doesn't have to come in sorted, but that when you are displaying it, it's easily understood or understood better when it is sorted. So you can do that very easily with bar charts, column charts, or even point charts. So when I look at something, I immediately know what the low item is on the category X or category Y, or the high item values. Part to whole, we talked about these a little bit earlier when we talked about pie charts, but there's other ways to display part to whole. Part to whole shows individual quantitative values associated with a set of categorical subdivisions related to the complete set of values against each other. So when I look at a pie chart, I have 100%. When I looked at a stacked column, I have a total percentage based on a category X value. If I have a stacked 100, I'm looking at 100% of that value within my range. So this could be a time series or any category series. It doesn't really matter. But it's going to come up out to be in a stack chart, a stacked area, stacked 100 area or column, a pie chart, or even a waterfall chart where I can actually see the variance in each data value across the distribution. So common units of measurement would be percentages, displaying percentage of total, the percentage of the share, something accounts for X percentage of something else. Again, when you're doing part to whole, it's recommended against using pie charts just because they don't make it very easy to read and understand the data. Use something like a stacked column or a stacked 100 for probably a much easier and much more common visualization. So deviations are one or more sets of quantitative values different from a primary set of values. So think about questions like, what's our head count change from month to month? What's a year-over-year comparison of sales? What's our actual sales versus our sales target? So units of measure are actual units, ratio relative to primary value, or positive or negative ratio. So when you think about showing a plus or minus, a variance, a difference, or relative to, you can use things like bar charts, column charts, or line charts to do that. So it's important when you look at something like a deviation that you are comparing something against something else, which is the base. So the base would be my head count was last year, what my head count is this year. Distribution shows how a set of quantitative values are distributed across its entire range from lowest to highest. Usually called a frequency distribution when it shows a single set of values. A single set of values, the number of times it occurs. So frequency of distribution is showing frequency, distribution range, concentration, or normal curve. So if you think about, I want to count the number of salaries for each employee in my company, it wouldn't make sense to list every employee and their salary. So what I have to do is come up with a distribution range to display that information. So I would have a distribution in my chart like less than 15,000, greater than or equal to 15,000, and less than 30,000, etc. So what it allows me to do is have a range of data which represents a portion of my distribution, whatever that might be. Now, a histogram can be used for this, a box chart, a line chart, column chart, scatter chart, even a 3D area chart is really good at showing concentrations or distribution. And then finally, correlation. So correlation displays whether two paired sets of quantitative values vary in relation to each other. They show the direction and the degree, high or low, positive or negative. So they're used to show things like relates to, increases with, decreases with, varies with, caused by, affected by, follows. So a typical use of a correlation is marketing expenses versus sales. So the existence of the correlation may indicate that one thing causes the other, which could be called a causal relationship, or that both things are caused by one or more factors. So correlation is something that we're saying, hey, I spent this much money in marketing and we got this many sales. Let's measure that over time, and then we can make better decisions because we believe that X causes Y, or the result of this caused something else. Correlation could also be something like, how tall our salesmen by region and how does that affect their sales. So I could have one data point that says height and another data point that says sales, and we could correlate that data together, and we might decide that the taller people actually are selling more stuff. That might be a little far-fetched, but it gives you the idea of different data points that you would actually correlate together. That's not all. There's other visualizations that, besides the 7 that Stephen Few sort of outlined and that we focused on for business charts. It doesn't mean that they're not important. They are very important, but they're not as commonly used. So geospatial maps are very important visualizations. Heat maps, bullet graphs, polar, radial charts, linear, radial gauges, and then something called the motion framework, which we ship with our product, which we'll talk about in the demos. So let's go ahead and do a few demos before we continue on. So let me bring up first off our WPF sample browser. So let me open this guy up here. Whoops. There we go. And this is something you can download, part of Infragistics Ultimate. But what I want to show you in the samples is really just some of the different visualizations that we have and some of the XAML and jQuery code that goes along with it. So in this case, this is the category series browser. And if I do the drop down here, when we talked about the data values that end up in the middle of the visualization, in this case the category series, so we have either a category X or a category Y axis. And if it's a category X, we have a numeric Y. If it's a category Y, we have a numeric X across the bottom. And these are the different types of visualizations that you can display. So here we have a stacked column, a stacked 100 column, area series, and you'll notice the different color schemes used, their relationship to the legend on the right hand side, and then the subtle animations as some of them pop up. So here's our line series, our stacked line, stacked 100, spline series, etc. I'm not going to go through each one of them, but I will show things like the waterfall series, which we talked about earlier, a bar series. And these guys, as I hover over, there's a little effect on the actual bar itself. Financial series is another series type. We have 2 kinds, a candlestick display mode and an open, high, low, close display mode. So those are just different visualizations. We have almost every financial indicator that you can imagine. So based on how you want to display your trends and your indicators, we pretty much have you covered as far as that goes. And you can display them in many different ways based on the visualizations that you'd like, lines, columns, areas, etc. And then we have financial overlay, so Bollinger Bands or the price channel overlay. So here's a price channel overlay, and there's the Bollinger Band. And you can have different periods and multipliers based on how you want to display these. Let's do different multipliers, less periods. But you can see that if you do change these at runtime, you actually have nice animations as well. Here's a scatter series. So we have the scatter series. Here's a scatter line series. So this is our point with lines. Scatter spline. And then our bubble series. And we also mentioned high density data. So what if you have, 1 million data points? So this is actually 1 million data points that just loaded up. As I zoom in, you can see that I'm getting all of these scatter plotted data. So now this certainly wouldn't make sense as I zoom in even further for something like a column chart. As I zoom out, you can see the entire distribution of data actually becomes a big black blob. Some of the other specialized chart types, here's a polar chart and radial chart. So as we push through these, same concept as a column chart, axis, a numeric x-axis, and a category Y. It's just displayed in a circle to tell a story, to get your point across. A lot of these are used in different verticals like science and medical based on what data you're trying to display. You can also have multiple series of charts. So here we have a financial chart with trend lines and a price series over the financial chart. And of course, all of the features like range selection and zooming work. You'll see on the bottom we have our time-based series, so the time values are changing over the day. And on our numeric y-axis, it's the volume. Different trend lines that we talked about earlier. This is just another view of those. So here's a cubic fit, cumulative average, exponential average, linear fit, logarithmic scale, modified average, power law fit. You can have different displays, so different dash arrays, solid lines, different dash caps, and of course a different thickness. And you can show those over pretty much any series. This is just using a financial price series and a point series. And I'm going to scroll down a bit. I want to show a couple more things. So this one is interesting, axis crossing. This actually will allow you to move the axis labels to wherever you want in the chart. So when we talked about earlier, putting information where it's most valuable to make it stick for the person, normally your x-axis ends up all the way at the bottom, your y-axis at the left, and it might not be evident as to what data points you're trying to highlight. So if we move them to a point in the chart where they can cross at a different vector, it'll make me look at that data a little bit more and maybe understand it a little bit better. And I'm going to scroll down a little bit more, and I want to show our motion framework. So this is an example of a very simplistic motion framework. I'm going to go ahead and hit run, and you can see that we actually have data points that are moving over time. So what the motion framework does is it takes your data incoming and it displays it over an interval value. So in this case we have it displaying over every 300 milliseconds. But it gets very interesting when you look at how we've implemented it in one of our jQuery samples. So at igniteui.com, if you click application samples on the left hand side, and you'll see we have a bunch of cool stuff here. So there's that marketing dashboard I mentioned earlier. Let's scroll down to world stats and launch this guy. So this really shows off the beauty of the motion framework and sort of what you can do with it. So I'm going to go ahead and bring this all the way to the beginning, and I'm going to hit play. So this is showing life expectancy by GDP over time. I'm going to zoom in a little bit for every country in the world. And you can see that countries are starting to move around, go up and down. As I hover over individual countries, I can start to see data. Now if I want to compare some countries, so let's compare Afghanistan to Australia, Aruba, and Canada, for example. So down here I have my line charts displaying on the time series, on my x-axis my time, which is the year, and on my y-axis the population. So it's showing population growth, and then it's highlighted on the top chart, which is a scatter plot, and individual values are moving based on the data of the year increasing. So you can see that Afghanistan life expectancy is still very, very low, where countries up here like Bulgaria and Albania, life expectancy is much, much higher. So let me try to zoom out here to show more data and look all the way up here. Canada life expectancy is 68, Afghanistan it's 30, Australia it's 71, Afghanistan, Yemen 34 years old in 1970. So let's fast forward a bit, and you can see some countries zoomed right up. Aruba zoomed up, some other ones, Trinidad and Tobago. But you get the idea. You had a beautiful animation over time, and it really does immerse your users in the data, and it really talks to that cognitive value that you can give your visualization so they stick with the users. So some other things here I would take a look at if I were you. All of the samples we have, all these beautiful different dashboards, and then as well, if you go to the jQuery controls and you scroll down and you look at things like the data chart, you will see all of the exact same examples that we had in the WPF sample browser. You'll have them over in jQuery as well. So even here, like binding real-time data. So here, if I add 50,000 data points, you can see that it's just booming 50,000 data points up that quick. And now I'm going to start this data feed, so it's actually displaying this data in real time. So that's pretty slick for being jQuery. And then finally, let's just very quickly, because I know I'm getting really short on time, take a look at some of the WPF examples. So here, if I just look at, for example, the bubble series charts, it's the same deal. Everything that you saw in WPF, you're actually going to get in Windows Forms, in jQuery, in iOS, everywhere else as well. So here I'll just keep adding multiple series so we can handle as many series as you want. Let's range select in and look at more data, zoom out, look at less data. And each one of these items we actually have the code for, so you can jump in, view the C# code, view the VB code, and the API and the capability ends up being exactly the same as it would be in JavaScript, as it would be in iOS, etc. So that's the work that we did to ensure that you have a great experience using those charts across the board. So let's real quickly go from some bad visualizations to some good visualizations. First off, when we talk about displaying stuff in shapes and volume, it's very, very difficult to read. So in this case, you can see we have the bank's market cap and the market value as of 2007. Very difficult to tell who is bigger, who is smaller, because you're supposed to visually be able to tell with your eyes how big these circles are, and then the volume that this circle takes within the larger circle. It's really almost impossible to figure that out. So in order to fix that, a better way to show this is in a simple bar chart. So very quickly now, I can see the market cap value in 2007 versus 2009, and then the percentage change on the bottom. So I go from something that's almost unreadable to something that's crystal clear and makes perfect sense. So visualizations can dramatically change the story that your readers will understand. This is something that's like chart art or chart junk, getting to know the homeless. For some reason, they thought that representing homeless people by these little stick figures, I would be able to tell how many were in each category of population, composition, etc. A much better way, just create a dashboard with some histogram data, point data connected by lines, and you can have very quickly homeless by age, homeless by ethnicity, homeless by location. But again, instead of going too fancy or getting too clever, stay simple, stay with something like a column chart, a histogram chart, a point chart with a line to display the data better. We talked about pie charts before. This is a little blurry on my screen. It's blurry on your screen too. But the point is, these are pie charts, and there's a legend, and you're supposed to relate the fact that that shade of green equals cash equivalents, or it might equal bonds because the colors are so close together. Much easier just to display several bar charts next to each other. You'll notice that each bar chart has a distribution of percentage on the left, but across the top we have a numeric x-axis. On the very left we have our category y-axis. So we have international, small cap, mid cap, and it spans all the way across each one of the charts. So a very interesting way of looking at the same data. Again, pie charts, very difficult to see. Not only is this a pie chart, but it's a 3D pie chart. Why not stick it in a ranked bar chart? Super easy to read. You can see percentages of the whole, and I can quickly tell that financials make up 21.45, the largest, and that cyclical consumer goods are the lowest at 1.87. And this is a sort of a shifted 3D line chart / area chart. Again, you can use a simple column chart to do this comparative analysis. Yes, we are using different colors to highlight based on our legend, and it's very easy to see that the company is on track. Most people strongly agree. Most people strongly agree they understand their goals. Most people agree that they understand their priority. You can tell that very quickly. You cannot really tell it from this graph. Too difficult, too complex. And then we have tables. Tables are good for some things, but other things they're not. So favorable or unfavorable views of the United States. This is super easy to read that Kenya has the most favorable view of the United States, while Egypt has the least favorable, and it kind of breaks down the difference between the highs, or the yeses, the nos, and the undecided. So looks like Poland, Britain, Japan, all pretty favorable. all the way down until we get to, I guess, under 50%. Turkey, Jordan, Pakistan, and Egypt. Egypt's very unfavorable of the United States. So there you go. But much easier to read than something like a straight line table. And then, of course, we can display another pie chart. This one's a total mess. It has annotations. It has arrows to highlight the data values. It's using lines and checks and dashes to show information. But at the end of the day, too much information. It doesn't make any sense. And we could easily have used a stacked chart to display this data. So we have percentages displayed on our numeric x-axis, and then our y category y-axis. We can see that extending enterprise users and the consumer is the highest, and the lowest producer is the IT user on the bottom. And then we have our 3D column chart. Anytime you're using a column chart in 3D, you very easily obfuscate data. It's very difficult to keep track of which line the data value actually is for our numeric y-axis. So why don't we just display it in a comparative column chart? So I have 3 series of data bound, and I'm showing US as the highest in 93 for Hawaiian Club. Actually, Hawaiian Club's the highest every year. Second highest is Bahamas Beach, and the lowest is French Riviera. So super easy to understand and get to this data. So some of the mistakes that we just saw was inadequate data context. We didn't really talk enough about the data that we're trying to display in those charts. We had too much detail in some. Some of them had deficient measures, which means that the measure actually didn't start out at 0 or was obfuscated, so it was hard to read. We had inaccurate encoding, similar to our 3D charts. Poor data arrangement. Pie charts are a perfect example of that. Ineffective highlighting. I think the table was an example of that because it was just kind of every other row was highlighted and it didn't mean anything, so there was no value to those highlights. Overuse of color in our 3D line area chart was a great example of that. And then unattractive visual display was probably all of them except the repaired one. So they were all pretty ugly. So it's really important that you think about the information you're trying to display and make it meaningful to your users so they get value from it. So what we learned today is charting can make complex data memorable. Most business charts can be visually encoded with lines, points, bars, and shapes. There are other options for business charts, but these are really the most common that you can use to display almost any type of business chart. Getting too fancy with charting visualizations can obfuscate their meaning and confuse your messages. And Infragistics Ultimate has all of the charts that you'll ever need to create any type of charting application. So I mentioned some great resources. Check out Juice Analytics. They have a chart chooser. It's interactive. It's all done in HTML. You sort of click on a category like relationship, trend, composition, distribution, and then the charts show up. It gives you an example, and it actually gives you an Excel sheet to download and play with that chart. This is a more complex, find the right type of chart for your data graph by Digital Inspirations. Here's the URL for this guy. It's actually really useful, but again, it doesn't really give you that second layer of information that you need, sort of the why. Like, why would I use this type of distribution? So I think if you revert back to something like what I talked about earlier, Stephen Few's books, Show Me the Numbers is the one that I got a lot of this information from. The chapter was called Fundamental Variations of Graphs. And his website, called perceptualedge.com, has tons of free articles that are great. And that's Stephen Few right there, kind of flicking out his hand saying, there you go, there's your data. This picture might be a little bit old, but anyway, I can't say enough about the information that Stephen Few has in his books and how valuable they have been to help me understand data visualization and charting and sort of drive what we do in our charting products to be better. And then, of course, Infragistics Ultimate. Download it today. Get all of our samples. We have these charts in every platform that you can imagine. You can even just go to the App Store and download them too for iOS. But if you want to do WPF, Windows Forms, HTML5, everything you saw today you can do with Ultimate. So with that, Here's my email, jasonb@infragistics.com. If you want to enter in questions into the chat window, we'll be online for a little bit longer, another 10 or 15 minutes. We'll follow up this webinar by posting it online with a blog. It'll be on YouTube in the next couple days. But I want to thank everyone for listening. I'm going to cut off the webinar now, but I will stay online and answer questions. So thank you very much for spending your time with us today.